Hello everybody, welcome to our lesson today on divisibility rules. This means that we'll be finding some pretty neat shortcuts to find out whether a number is divisible by 1 all the way to 20. Alright, so with that being said, let's begin. Alright, so the first one is, 1, which is pretty straightforward. Pretty much everything is divisible by 1. Moving on, we'll go to number 2, which is luckily still pretty straightforward. Right, as long as a number is even, it is divisible by 2, including 2 itself. So it could be things like 4, 16, 20, that kind of stuff. In order for a number to be divisible by 3, we will add all of its digits up. Right? So we add the digits up, and if that sum is divisible by 3, then the original number is also divisible by 3. Right? So let's do a couple of random examples here. We got 516, we got 292, and 111. Alright, so let's add those up. For 516, we have 5 plus 1 plus 6. This gets us 12, right? We know 12 is divisible by 3 from the multiplication table, which means that 516, the whole number, is divisible by 3. Alright, next we have 292, so 2 plus 9 plus 2. That will fetch us 13, which isn't divisible by 13, or isn't divisible by 3. So 292 is not divisible by 3. Right, it was 111, that one's easy. 1 plus 1 plus 1 gets us 3, which is divisible by 3. Which is kind of cursed. 111 shouldn't be divisible by 3, but it is. Right? And if we just quickly do the math here, let's see. 516 divided by 3, that's what? 172. Right, 292. What do we have here? That's 9, that's 22. So it'll be 97 remainder 1. And lastly, 111 divided by 3. That we've got 3, 37. Right, you can probably use that to scare your friends. 111 is divisible by 37. Alright, so moving on to 4 now. Right, with 4, as long as the last 2 digits are divisible by 4, right, then the whole number is divisible by 4. Right, so let's take 104, 1,321, and let's do a big one, 59,324. Right, so we look at the last 2 numbers. We have 0, 4 for the first number. 0, 4, or 4 is divisible by 4. So 104 is also divisible by 4. Right, last 4 numbers here, 21. 21 is not divisible by 4, so 1321, not divisible by 4. And lastly, even doesn't matter how big the number is, if just the last 2 digits is divisible by 4, then the whole thing is, right? So 24 is divisible by 4. Just we can just check the last one real quick. I don't know why I did that. That's gonna take a while. Okay, let's see. So we have 1, that's 19, 4, that's 3 left over, 1, 3, 1. Okay, is that right? 4, 2, 3, 6. Oh, that's right. Okay, there we go. So yeah, this big number is divisible by 4. Alright, 5, nice and straightforward. 5, everything is divisible by 5 if it ends in a 0 or a 5. Could be anything, right? 1,1,625. Yeah, see, if it ends in a 5 or 0, it works. Alright, when it comes to 6, this is interesting because 6 itself, right? 6 itself is just 2 times 3. So, which means that if a number is divisible by 6, it must follow the rules of the 2 and the 3. Right? So it first has to be even, and let's just say like the rule of 3. Right? So if it fits both criteria, then the whole number is divisible by 6 as well. Right? So let's take the example 516 again, 134, and let's do 2,478. Alright, so if we start here, 516, we know it's even, which is good. And also, 5 plus 1 plus 6, once again, we knew it was 12. Because this number both is divisible by 3 and it's also even, it's also divisible by 6. Right, so now let's take 134, for example. 134 is even, so if it's divisible by 2 for sure. But if we add up all the digits, we get 8, which is not divisible by 3. So even though it's divisible by 2, it's not divisible by 3, which means it's not divisible by 6. Lastly, for the big number, we add all the digits up. What do we get? 8, 15. No, 6. 6, 13, 21. All right. This tells us the last number is divisible by 6 because it's also divisible by 3 and it's even. All right. So there's the first 6. Let's go to 7. So with 7, here's an interesting one. Right? So we double the last digit. We subtract it from the number. If that number is divisible by 7, the number is as well. Alright, so that probably sounds like gibberish, which is okay, right? This is easy to illustrate with some examples here. So let's take 224, 627, and 7084. So with 224, we double the last digit. So we get 8. And now we take the remainder of the number. So we took away the last digit. All we have is the first two numbers, over the first two digits. So we have 22 remaining. We subtract the 8, we get 14. Right? We know 14 is divisible by 7, which means that 224 is also divisible by 7. Right? Similarly, we take the last digit of this number, we got 14. 62 minus 14. Let's see, what is that? 6, 8, 48. Right? 48 is not divisible by 7, so 627, not divisible by 7. Right? That's a big number here. We double the 4 again to an 8. 708 minus 8 is 700, which means that 7084 is divisible by 7. We can do this quickly. This comes out to be 1012. Right? So yeah, it's a really weird trick, but it works surprisingly. Right? For 8, right, this is similar to 4, where the last 3 digits is divisible by 8, then the number is as well. Right? So the examples for this one, we can just do 128. We have 1108, and we have 67,128. Right? So 128. Unfortunately, we can't really check this one. Right? We just have to check it manually. So because again, we're taking the last 3 digits of the number. Because 128 is 3 digits long, we will have to check this manually. Right? So let's see. We have 128 divided by 8. Let's see. That's 1, 6. All right, cool. So that's divisible by 8 just because we checked it. Right? But now let's do a more relevant example now. Take 1108. It's 4 digits, but we can just take the last 3 digits. All right, 108. Is 108 divisible by 8? Let's see. We get a 1 here. We have 28 left over, which unfortunately does not divide to 8. Right? This will give us 13 remainder 4. Right? Because the last 3 digits of this big number is not divisible by 8, then the whole number is also not divisible by 8. Alright, so now for the last one, we take 128. So once again, we know the 128 is divisible by 8. Right? Which means that 67,128 is then divisible by 8. This could be anything. It could be 99,128. That's also divisible by 8. Alright, moving to 9 now. This is similar to the 3 one. Right? So we add digits up. If it's divisible by 9, then it also is. Right? So this is similar to 3, like I said. Let's take the example 1026, 452, and then 7,686. Right? So we just add the digits up. So we got 1 plus 0 plus 2 plus 6. That gets us 9. That's divisible by 9. So 1026 is also divisible by 9. 4 plus 5 plus 2 gets us 11. not divisible by 9. So 452, not divisible by 9. Here comes a big number. 7 plus 6 plus 8 plus 6. That is 21, 27. 27 is divisible by 9, so the big number here is also divisible by 9. Alright, very cool. 10, super straightforward, ends in 0. No exceptions. Including 0 itself. 0 is divisible by any number, right? Alright, so now done with the halfway point. To be completely honest, everything else beyond this point is probably easier to check with a calculator, right? Checking 11, 12, 13. It's probably fast with a calculator. But just for the fun of it, let's go over them anyways. Right, so going on to 11 now. Right, with 11, we alternate adding and subtracting digits if the sum, right, so if sum is divisible by 11, then the number is also. Alright, so here's a pretty fun one actually. Alright, so let's again, we'll only be working with big numbers here. 82,412 equal 12,432, 97,000, or no, we're making it bigger, 971,828. Right, so we're going to alternate in a plus minus pattern. Right, so we have plus 8 minus 2 plus 4 minus 1 plus 2. Right, this will give us 6 and then 10 and then 9 and 11. This pattern gives us 11, which means that 82,412 is divisible by 11. Right, next we have the second one we got, again, we start with a plus, so plus 1 minus 2 plus 4 minus 3 plus 2. That's a weird number. Okay, negative 1, 3, 0, 2. Right, so this 2 is not divisible by 11, so the whole number is not. Lastly, plus 9 minus 7 plus 1 minus 8 plus 2 minus 8. Right, so we got 2, 3, negative 5, negative 3, and negative 11. Despite being negative, negative 11 is still divisible by 11. So this big 971k is also divisible by 11. Right, so pretty cool stuff. But like I said, it's probably faster to check with a calculator, to be honest. Right, but still pretty fun though. Okay, speaking of fun, 12 is actually pretty easy. Right, so 12 can be expressed, actually, should I say, as 4 times 3. Which means that it follows the rule of 4 and 3. Rule of 4 and 3. So which means that if a number is divisible by 12, it must first add up all the digits, and the sum is divisible by 3, and the last 2 digits is divisible by 4. Right, so I could just, let's make one up just on the spot. What do we have? Something divisible by 24 at the end. Let's say, or not divisible by 24. Something divisible by 4. We got 24 at the end of this number. Actually, I can just go with this, right? 24 is divisible by 4. 2 plus 4 is 6. So 24 is divisible by 12. Let's see. Let's add like a 5 here, a 3 here, and a 1. Right, so take this number for example. 24 at the last 2 digits, divisible by 4. We add all the digits up. That's 8, 9. Right? That's 9 plus 2, 11 plus 4, 15. Right? 15 is divisible by 3. So we can see this number, it will be divisible by 12. Okay, 13. It's also weird like 7, where we 4 times the last digit. Right, we 4 times the last digit. We add, so not subtract, we add to the number. If that's divisible by 13, then the number is as well. Alright, so let's do some random numbers here. So 182, 756, and then 195. I guess they're not really random. I wrote them ahead of time. Right, so we 4 times the last digit, so this is an 8. We add it up. We got 18, which is the remaining 2 numbers, or the remaining 2 digits. 18 plus 8 gets us 26. 26 is divisible by 13. 182 is also divisible by 13. Alright. Quadruple the last digits is 24. 75 plus 24 is 99. 99 is not divisible by 13, so the whole number is not. And lastly, we quadruple to get 20 here. Remaining digits is 19 plus 20, we get 39. 39 is divisible by 13, so 195 divisible by 13. Cool. 14. Same rules. So 14 is 2 times 7. So follows the rules of 2 and 7. 15 is 3 times 5. Follows the rules of 3 and 5. Alright, so for 16 here, at this point, like I said, calculus is probably easier, but still interesting why it works. Last 4 digits, divisible by 16. So I can just make one up a spot. 16 is divisible by 16. So if I give the number 7,000 or 70,016 here, the last 4 digits is 16. So 70,016 is divisible by 16. Alright, 17. The weird rule again, where instead of 4 times, got 5 times. So 5 times last digit. Alright, 5 times last digit. We subtract this time. Confusing for some reason. Subtract by number from, there we go. From the number, if divisible by 17, then the number is as well. Alright, so now let's take 629 as an example. Right, 9 times 5 gets us 45. 62 minus 45, that will get us exactly 17, which is divisible by 17. Meaning that 629 is also divisible by 17. Right, when it comes to 18, right, so 18 is 9 times 2. So it will follow the rules of 9 and 2. Right, which means that all the digits added up has to be divisible by 9. And it's an even number. Okay, so now let's do 19. This is similar, but again, different to the 7, the 13, and the 17 here. Right, so we double the last digit. Right, but instead of 7, when we subtract, we add to the number. If this is divisible by 19, the number is also. Right, so the example here is just 113. Nice and easy. Right, 3, we double that to get 6. And then we got 13 as a remaining number plus 6, getting us 19. Right, so very quick one for this one. 133 is divisible by 19. Alright, so now for 20, this is a weird one. Normally, or intuitively, we could just do follow the rules of 4 and 5. Right, which again, definitely works. But an easier way to think of it is that the number has to end with a 20, a 40, 60, 80, or 2 zeros. Right, a number has to end in one of those 5. So for example, 4,540, right, it ends in a 40, so it's divisible by 20 as well. Alright, so that was a lot. There was a lot of divisibility rules. So just to end off the video, we'll do a quick little exercise, right? So I'll write the question down right now, and I want y'all to pause the video and try them out, right? So again, I'll be writing our 4 numbers, right? So we'll do, say, 231, 221, 244, and 133. So pause the video here, try to see what divisibility rules you can use to try to figure out what those numbers are divisible by. Alright, I'm pausing now. So 231. Right off the bat, we can add everything up. We add everything up, we get 6. So this is divisible by 3. Another one we could do is the 7 rule, right? We double the last digit. So we double the last digit to get 2. And then we subtract it from the whole number, getting us 21. That's divisible by 7. So it's also divisible by 7. The last one is the 11 rule. So we add the 2, subtract the 3, plus the 1. We get 0, divisible by 11. So 231 is divisible by 3, 7, and 11. Okay, next, 221. So 221, we have to do a bit of trial and error. Alright, so there's a bit of a trial and error for the last one here, 221. So it is divisible by 13 and 17. with that being said, we can do 4 times the last digit, getting us the 4. And then we add it to the remaining number to get 26. Showing that it's divisible by 13. And then for the 17, right, we 5 times the last digit, right? And then we subtract from the whole number to get us 17, right? 17 right here. Again, no shame if you use a calculator here. This is a pretty big stretch. Right? And then this one is a bit more relaxing, if you can put it that way. Right? We can look at the last two numbers here, which is 44 divisible by 4, which means that this is only divisible by 4. Well, it's also divisible by 61 here. Alright, but again, that we probably won't get to that far. Alright, so for the last one, it's divisible by 7, first of all. Right? We can find that by doubling the last digit and then subtracting. Right? We subtract, we get a 7, which means that this is divisible by 7. And also it's divisible by 19. So we double the last digit and then add it to the rest of the number. We get 19, meaning that it's divisible by 19. Right? So, like I said, that was a lot of stuff we just learned, but I hope that you all learned something interesting. So now why do we do all that? Why do we spend this much time just learning about divisibility rules? So a really nice way to use divisibility rules is for finding the factors of different numbers. Reducing fractions is also very important. Right? If we can quickly find out what number is divisible by, we can quickly reduce our fractions and figure out, oh, we can just divide both numbers by 3 because they like add up and it's divisible by 3. Right? It's also really useful for finding the lowest common multiple, again, with fractions, which we'll probably talk about another time. Right? So yeah, thank you for checking out this lesson today. I hope that you learned something, and yeah, stay hydrated.